addition, subtraction, multiplication, and division. You can combine numbers using the 4 operations. You can combine functions using those 4 operations as well. The other thing that we're going to also talk about with each one of these is not only finding the function, but also finding the domain. Because each one of these could have a restriction on it. Anytime there's a restriction on a function, we need to list that restriction. And that's because if you have a square root, you can't just plug any number in for x if you were asked to evaluate. So before we do a, b, c, and d, if you look at the 2 functions, what would the restriction be, or what's the domain of the first function f of x? So we have the square root of x plus 2. What's its domain? So think about what has to happen with the square root. Brenton?
Zeros.
What can't be underneath the square root?
Cannot be 0.
It could be 0.
It can't be negative.
It can't be negative. So that means this has to be greater than or equal to 0. And then what does that make the domain then? So if it can't be negative, it has to be greater than or equal to 0. So what's that make the domain?
0.
Negative what? For this guy here?
2.
2. So negative 2 to positive infinity. So if I solve that little equation, the square root of x plus 2 has to be greater than or equal to 0. Square both sides, you end up getting x plus 2 has to be greater than or equal to 0. So x is greater than or equal to 0. Or sorry, greater than or equal to negative 2. So that means it goes from negative 2 to positive infinity. Essentially, whatever number in there makes it 0, it can't be any less than that. So then looking at the second one, g of x equals the square root of x minus 3. What's the domain of that g function? Emma? Right, negative, how about positive 3 to positive infinity? So those would be the individual domains. And then we're going to talk about how you would find a domain of the combination of the function. So the first question says take f of x plus g of x. What are you going to do to take f of x plus g of x? What's the f of x function? Colin? What's the g of x function, Colin?
Square root x minus 3.
Literally, you're taking the equation that represents x, adding it with the equation that represents g. Now, can you truly add these equations together? No. They're not like terms. Square roots have to be identical in order for us to add them together. So if this said 2 square root of x plus 3 square root of x, that would make 5 square root of x. But if whatever's underneath the square root isn't the same, you actually can't do anything more to simplify it. I'm showing that I'm adding them by having the plus sign in between. So that would be doing the addition, combining them together using addition. Next to it, I want us to list the domain. When you look at the domain, you have to find the overlap of the 2 functions. So looking at the 2 separate domains, the first one from negative 2 to infinity, the second one from positive 3 to infinity, what would be the domain that works for both? So I can't be like, well, this domain I could apply to this one I could apply to that one. I need an overlapping domain to work for both now that we've combined them together. What would be the overlapping domain that would work for both? Colin?
Bracket -2, 3,
So you're making it too hard. Garrett.
Bracket positive 3. Infinity parentheses.
So Colin said negative 2 to 3, and then he said 3 to infinity. Why can't you use negative 2? Garrett, why can't you use negative 2?
Because it doesn't apply to the positive 3.
Yeah, it doesn't apply to the positive 3. So if I plugged a negative 2 into this second piece of the equation, because now it's an equation combined together with an addition sign. So whatever my x is, I would plug in for both x's. And if I plug a negative 2 in, I have the square root of negative 5. I can't take the square root of a negative 5. So, same thing with 0. If I plug a 0 in here, I can't take the square root of negative 3. The first number that works, that I could plug in, is 3. So even though the one on the left has a larger domain, the overlapping piece that would apply to both would be from 3 to infinity. So you're looking at the answer and trying to see what would be the domain of both of those pieces combined together. Questions? So really the one with the smaller domain is the one that applies to both. So looking at letter B, this one wants us to subtract, which really isn't any different than adding. So my f of x function, that's staying the same. It's just I now have a subtraction sign in between the two functions. That's it. Again, I can't really subtract these. You don't distribute the negative underneath because there's not a negative underneath, it's outside. And then, does the domain change just because it's subtraction? No, because the domain affects what's underneath the square root, not the subtraction sign outside. So this domain still would be from 3 to infinity, with the 3 being included. The third one says take f of x times g of x. So we'll see what that does. Square root of x plus 2 times square root of x minus 3. Can you actually multiply these? Yes. So multiplication has different properties than addition and subtraction. I can multiply an x and an x squared together. I can't add them because they're not like terms, but we can multiply them. As long as they're both the same square root, cube root, fourth root, we can actually multiply them together. And the way we multiply them would be to stick them underneath the same radical, because if they're individually underneath the square root and I'm multiplying, then I can combine them together as well. It means the same exact thing. And then multiply them. So what would that become if you multiply them together? Anna, what does it become?
X squared minus x minus 6.
The domain, however, does not change. It's still the same from 3 to infinity. So bracket 3 to positive infinity. Because if I plug a 3 in here, I still get the square root of 0. Because when you're multiplying, that would give me a square root of 0. But if I plug a negative 2 in, now I have a negative value, and I'm multiplying it by a positive value, it's still going to be negative. So can't have that negative number in a radical. Questions? So the last one wants us to divide the two functions, so pretty straightforward like we've done all of them. F of x is the square root of x plus 2. G of x is the square root of x minus 3. So knowing with multiplication that since they were the same radical, we combine them underneath 1. Multiplication and division are inverse operations. They have the same properties. So I can combine them underneath 1 radical since it's the same radical. Can anything cancel underneath that radical? Emma? No. Even though you're saying, yeah, but both of those are x's, I could just cancel out that x because it's the same. The x on the top has a plus 2 with it. They're combined together. The x on the bottom has a minus 3. And I can't just cancel a piece out because then you're taking away that 1/2 of it. And they're combined together with that minus or plus sign. So this will be how it remains. What's the domain? Thinking about it now being a fraction. Quentin.
Would it be parentheses 3 positive 3.
And why do you say a parenthesis instead of a bracket? Right, so you can't have a 0 in the denominator of a fraction. If it was 3, you'd have a denominator of 0. So that's the only difference. So like the domain for any of the combinations are going to be the same, except if it's in the denominator. Questions? So see if you can try the second one. Don't let the notation confuse you. So we have these two functions, 2x plus 1 and x squared plus 2x minus 1. A says find f plus g, and then x is outside, and its domain. What is that really asking you to find?
Find f of x plus g.
Yeah, it's just a different way to write it. So we can write it combined together with the functions together, or we can write it separate. So see if you can find f of x plus g of x, and then think about the domain. And then part B, I want you to find f plus g of 2, which really means find f of 2 plus g of 2. So you can write it two different ways. That 2 is applied to both functions. So Lauren, if you combine them together, add those two functions, what do you end up getting?
X squared plus 4x.
Yeah. So f of x plus g of x would equal x squared plus 4x. What would you do for part B? Hannah, I'm sorry.
Easy. You plug in the 2 into each of the equations and add
Yeah, so she said plug the 2 into the equations to find the value. What's another way you could do it? That's one way. Yeah, you can plug them into the x squared plus 4x because the operation is addition. So we already added the two equations together. You're going to get the same answer either way. So you can plug them in individually. Or I can plug them in down here. Because I've already done the operation part. I've done the addition part. Now it's just kind of using that too. But either way, you should get the same answer. So 2 squared plus 4 times 2 is 12. Up here, we have 4 plus 1. 4 plus 8 minus 1. Something's not right. Did I miss
Yeah,
something?
8 is a 4.
Oh, right here. Thanks. That's not right. There we go. So that also gives me 12. What's the domain of the function for a? X squared plus 4x. What's the domain, Josh?
Negative infinity to positive infinity.
Why?
Because there's no values of x that could
Yeah, exactly. There aren't any restrictions because there isn't a value of x that would make it 0. That would be in the denominator. There isn't a value of x that makes the square root negative because there's not a square root. Questions? So I think there is one other problem underneath here. We have the square root of x and then the square root of 4 minus x squared. Oh, I guess there's two more. This one wants you to find f of x divided by g of x, and then again it says its domain. So I think the f of x divided by g of x, that guy's pretty easy. So taking the square root of x, dividing it by the square root of 4 minus x squared. Which really means I have the square root of x, 4 minus x squared. But we need to talk about the domain. So if you go back to the original two functions, and look at them. Our goal is to find out the overlap of the domain so that it works for both. So what would the domain of the square root of x be? Just the square root of x. What's its domain? Emma?
Bracket 0 to
Right. So that's allowed to go from 0 to positive infinity. Now let's look at the other domain. So we have the square root of 4 minus x squared. So doing a little side work here. That has to be greater than or equal to 0. Hannah?
bracket 2 positive infinity.
So she said bracket 2 positive infinity. How'd you get that?
Well, I know that 2 squared is 4, so 4 minus 4 is 0.
So 2 squared, okay. But what other number could it be? Negative 2. So really, if I have negative x squared greater than or equal to negative 4, that would be really a positive x squared, positive 4. I got that plus or minus when we take the square root. There's 2 numbers in there that would make it 0. Then we got to figure out, you got this interval, which one of the intervals work, or do 2 of them work? So if I plug in a negative 3, I would have 4 minus, and then negative 3 squared is 9. Well, 4 minus 9 is negative 5. That doesn't work. But if I plug a 0 in, 4 minus 0 squared is the square root of 4. The square root of 4 is good. So here this piece works. And then over here, if I plug in a positive 3, again, 4 minus 3 squared is 4 minus 9. And 4 minus 9 is the square root of negative 5. So that's not going to work. Anytime there's 2 answers, you got to think about those intervals. So the interval is a bracket with a negative 2 and a bracket with a positive 2. That's for my other domain. So then the question is, where is the overlap? Which numbers work for both? So looking at both domains, the one domain says it has to start at 0 and go the whole way to infinity. The other domain says it's only allowed to go from negative 2 to positive 2. What do you think?
Bracket 0, 2, bracket.
So he said bracket 0. It can't be anything less than that because it wouldn't work for my top. And then he said to 2, and you were 95% there. Why can't you put a bracket around the 2? Where's that equation?
Oh, if you have 2, then it would equal 4, and then add 0, so
It gets a parenthesis. There's a lot to think about. So the actual function part, doing the division part, that's the easy part. The domain is harder. So thinking about what's the smallest number that it can be so that you can still plug it into both square roots. What's the largest number it can be so you can plug it into both square roots. And then it's a fraction. So that means my other number, if I plug that into the denominator, it would be 0, and I can't take this, or have a 0 in the denominator. So there's one more question, I think, number 4, that's like squeezed in there. So it says f of x, or f plus g of x, which is really f of x plus g of x. So what is the domain of this function? The domain's the part that's a little trickier. If I actually added them together, we can just keep it like this. Yes, we can get a common denominator. I have 1 over x plus the square root of x. The goal is to think about the domain. So find the domain individually, and then try and get that overlap. So Garrett, the first one is 1 over x.
So x cannot be equal to 0.
So that means the domain would look like,
Let's see 0 to positive infinity.
and also negative infinity to 0. The other domain, Garrett, if it's a square root, the square root of x has to be
Greater than or equal to 0.
greater than or equal to 0. And I think Garrett was actually giving me the final domain. So he said 0 to positive infinity. So it can't be a negative number, that's why that excludes that domain because the square root. It can't be 0 because it's in the denominator. So that means it has to go from 0, just past 0, to positive infinity. Any questions with getting the domain of those functions? The easy part's adding them together. The domain you've got to think a little bit about. So the other type of topic we're going to talk about today are the composite functions. So these are all combinations, adding, subtracting, multiplying, and dividing. A composite function is this crazy notation that f with the little dot, g, and then the x next to it. There are two different ways you can write this. This is in your notes at the bottom of the page. Remember, we read this as f of g of x. So the function outside is f. Parentheses really means the word of. My next function is g, and then the parentheses, and then the x. And you don't say anything for the other two. F of g of x. A composite function is taking the inside function and plugging it into the outside function. So this is more like substitution than it is adding, subtracting, multiplying, or dividing. It says the domain of the composite function is the values of x in the domain of g. So essentially you need to look inside. What's the domain of the inside function? And then how does that apply to the outside function? So we're worried to focus on the inside. How does that inside then apply to the answer or the outside function? So the next page has a couple examples of composite functions. And again, you can write them two different ways. So you might see that little circle, that open circle isn't multiplication. It really means it's a composite function. So we have this f of g of x. Does anybody remember how you work on evaluating or finding that? What do you remember?
The two plugins is like what g of x equals for the x and what f of x is.
Yeah, so he said plug in g, whatever g of x equals. So g of x is x plus 1. I'm going to replace g of x with whatever it equals, as he said. And then you plug that into
Would you plug that in for?
You were right. So what do I do from here? What do I do with the x plus 1? So I took out g of x, as he said. You replace it with the x plus 1, because g of x is equal to x plus 1. Josh,
Square it,
why do you square it?
because that's for like x.
Yeah.
Substitute.
So now look at your f function. Your f function says it's supposed to be something squared. That's your function for f, or for f. So whatever's in parentheses needs to replace the x in that function. Well, it's supposed to be squared. So we have x plus 1 squared. Josh, what is x plus 1 squared?
X squared plus 2x plus 1.
Yeah. So it's a composite of both functions combined together. So it's the g function that was in the middle applied to the outside function. So the other one is pretty much the opposite. So this time in the middle is the f function. So we're going to take that middle function, which is x squared. And then you're applying that to the other function. So look at the middle, use the middle function and apply it to the other one. So the other one said x plus 1. Well, my x is now x squared. So this is x squared and then plus 1. So you can see the function inside applied to the outside function. So I still have x plus 1, but my x has been substituted or replaced. See if you can try the next two problems underneath. Again, composite, using the other notation. Whatever variable's first is the variable on the outside. So this is f, that little circle is a dot. That's what we call it, like f dot g or f of g. The second variable or function goes on the inside. So the f is first, it goes the outside. So combination for operations. Composite or composition is more of substitution, taking the inside function, substituting it into the other function. So Dylan, what does the first one look like when you substitute it in?
4 minus x squared plus 2.
Yeah. So this piece here represents x, and then it said plus 2. And Dylan, if you combine your like terms, you end up getting,
Negative x squared plus 6.
or if you like having this 6 first, because you like starting with a positive number, you get a 6 minus x squared. So f of g of x is equal to x, negative x squared plus 6. So the second one, what do you have there, Hannah?
I said 4 minus x plus 2 squared.
And put in parentheses around that. What is x plus 2 squared when you FOIL that?
X squared plus 4x plus 4.
What's that negative sign applied to that was in front of the parentheses? Does it just stay with the x, or does it apply to everything that you just FOILed? Everything. Because x plus 2 squared was in parentheses, separate from the negative. When you FOIL that, whatever your answer is, when you FOIL it, all of that's supposed to become negative. So this is now 4 minus x squared minus 4x minus 4, which means we have negative x squared minus 4x. Or if you like taking the negative out, x squared plus 4x. Questions? So I think there's one, nope, I thought there was one more example like this. There's none that ask us to plug in numbers. Oh, there's down below. Okay, I just have mine opposite. So example 7 is kind of the opposite. So it says find the functions f and g such that a composite function f of g of x is going to be equal to x. H of x, sorry. So it says h of x equals x squared plus 1 to the 50th power. So we have this function that we're calling h. That's our composite function. So that's the answer to the problems you have above. Our goal is to piece it apart to find the original 2 equations. So what equations will we start with? Or we would combine them together and get the answer. So it's like you're doing the opposite. You have the puzzle put together, we want to pull the puzzle apart. So our goal is to find out if this piece here represents f of g of x. What is the f function? What is the g function? So separate it. What would it look like if you separated it? What would the individual functions be? So where would the g function be located? So look above, like where was g located? Anna? In the parentheses, because it's f of g of x. G of x is in the parentheses. So if I go to my function here, g of x is in the parentheses. whatever's inside the parentheses in one function should be inside the parentheses in the other. So g of x is x squared plus 1. What does that mean f of x is then? Yeah, x to the 50th. Because if I take this out, well, I still have to have a variable remaining, and that variable would be x. So if I take this out, then I'm just left with x to the 50th power. So now I have my two original functions. You could check your work and try and combine them back together and make sure you get that new function. But you're like pulling the pieces apart, separating the two functions. The next one is pretty much the same thing. So h of x equals 1 over x plus 1. So this piece here really represents f of g of x. Since g of x is in the parentheses, that's the equation that was substituted in. Lauren, what equation was substituted in?
X plus 1.
Yeah, x plus 1. If I take that equation out, I'll write it underneath here. What would your f of x function be, your outside function line?
Is whatever x.
Yeah, 1 over x. So if I take this bottom piece away, I'm left with 1 over something. Well, it has to be 1 over x. Any questions? They're different. They kind of make you think backwards. So I have the thing put together. I got the composite function. I want to separate it into two pieces. I think there's one question at the bottom. This one actually asks you to find the domain. So the first part, find f of g of x. So Gabby, what would f of g of x be equal to? So if we have x minus 1, or g of x,
So f of x be square root of x.
square root of x
Oh,
minus 1. So whatever's in parentheses is replacing x. So now it's the square root of x minus 1. What's that domain? So we have a square root. Square root can't be negative. So greater than or equal to 0. Emma, what's that domain? Right. So its domain would be 1 to positive infinity. So now it asks you to evaluate. The first one is f of g of 2. Well, I found f of g of x. We already did the finding part. That's the equation. What are you going to do with the 2? Nick, what would you do with the 2? Plug it in. What's the square root of 2 minus 1? 1. So f of g of 2 is 1. How about letter C? F of g of 0. Josh, what do you have for letter C?
I just said like not possible
Why not?
because well, first of all 0 doesn't fall within the domain.
Yeah.
It just doesn't
0 isn't in the domain. If it's not in the domain, it's not possible. So you would say it's undefined, there's no solution. One of those two words. You don't even need to plug that in. If you recognize that they're giving you a value that's not in the domain, no work necessary. 0 isn't in the domain. I think there's one final question that should be a difference quotient that we quite didn't get to. We've done some difference quotients problems. This is not anything different, just a little review of the difference quotient. So I'd plug in that x plus h in for x, and then I'd subtract the second function, and then we would simplify. So you're still gonna see that difference quotient. That thing's never going away. Even next year, it will not go away. So book homework tonight on combinations and composite functions. Somebody interested in doing 15 or 43? Hannah and Emma? Hannah 15, Emma 43? Have a fantastic day.